Hi everyone, welcome to Orchify AI. In this channel, we build and showcase real-world AI solutions that business can actually use. In today's video, I'll walk you through how we built an AI-powered customer support voice assistant using Livekit. What if your customer support team could answer every call 24 hours a day, 7 days a week without hiring any more people? In this video, I will show you a real AI voice assistant that we built and is live on our platform at Orchify AI. This is not an idea, we've actually built the solution. On Orchify AI, we create AI systems that solve business problems like automating customer support. Many businesses have trouble with customer support. Calls are missed, responses are delayed, and costs are rising. Hiring more support staff is expensive, and not doing so means losing customers. So, we created an AI voice assistant that can handle customer conversations from start to finish. It can understand what customers are asking, ask follow up questions, and respond away, just like a human customer support agent. So, let's check out the voice assistant live implemented for a demo of a SaaS solution called Flow CRM, which is a unified system to manage leads, contracts, accounts, and opportunities.
Hello, how can I assist you today?
Hey, I wanted to check, can I change my email address associated with Flow CRM?
Let me check that for you. One moment, please. You can set up your preferences, including email integration settings, by going to your profile icon, selecting settings, and configuring various options. However, there's no explicit information about changing your email address associated with Close CRM in the provided documents. To confirm or get detailed steps for changing the email address associated with your Close CRM account, I recommend checking the settings section under your profile in Close CRM. If you need further assistance, let me know.
Yep, thank you.
You're welcome. If you have any more questions or need further assistance, feel free to ask.
Yep. So here we saw how an AI voice assistant helped customer answer his or her query about the solution. Now let's check that under the hood how it was implemented, what was the technical architecture, and how did we actually code the solution. Now let's break down how this AI voice assistant actually works behind the scenes. This is the complete end-to-end pipeline, starting from when a customer speaks all the way to receiving a real-time AI-generated response. It all begins with the caller. A user speaks through a phone call or web-based voice interface, and the system captures this audio input in real time. The next step is speech to text. We use Deepgram to convert the user's voice into text almost instantly. This step is critical because low latency ensures that the conversation feels natural and responsive. Once the speech is converted into text, it is passed to the language model. Here we use GPT-4o Mini. This is where the core intelligence of the system lies. The model understands the user's intent, processes the context of the conversation, and determines the appropriate response or action. Now, in many real world scenarios, answering a query requires external data. For example, checking an order status or receiving product information. To handle this, we use RAG pipeline through n8n. This allows the system to fetch accurate and up-to-date information from external databases, APIs, or knowledge bases, ensuring that the response is not just intelligent but also factually correct. Once the response is generated, the next step is to convert it back into voice. For this, we use ElevenLabs. This ensures us to generate natural, human like speech, making the interaction feel smooth and conversational. Finally, the response is delivered back to the caller in real time. Beyond this core flow, there are a few capabilities that make the system powerful. First, it can handle complete customer support interactions through voice without requiring human intervention. Second, it integrates with external systems to fetch dynamic and accurate information. And third, it maintains session continuity, meaning it can preserve context across the conversation, making the interaction feel coherent and connected. If we quickly summarize the tech stack, we are using Deepgram for speech to text, GPT-4o Mini for reasoning and decision making, n8n for orchestration and retrieval, and ElevenLabs for text to speech. The key idea here is orchestration. Individually, these components are powerful, but when combined in a single pipeline, they create a seamless, real time AI system. And this is what enables business to automate customer support efficiently and at scale. This entire pipeline runs in just a few seconds, but it can replace hours of manual effort. Now, before we jump into actual code, let's quickly look at how the project is structured. This gives a high level understanding of how everything is organized and how the different components come together. At the core of the project, we have the main applications inside the SRC folder, where the primary agent logic resides. The agent.py is essentially the entry point for our voice assistant. This is where we define how the agent behaves, how it processes inputs, and how it integrates with different services. Next, we have pyproject.toml file, which manages all dependencies required for this project. This includes integrations for Livekit, speech to text, LLM processing, and text to speech. We also use environment variable files like .env.local to securely store our API keys and runtime variables. This allows us to keep sensitive information separate from codebases. Additionally, we have a virtual environment setup to manage Python dependencies cleanly and a Docker file for containerized deployment if we want to run this project in production environment. On the right hand side, you can see the dependencies that power the system. Livekit for real-time communication, Deepgram for speech recognition, OpenAI for reasoning, and ElevenLabs for voice generation. We also defined environment variables for connecting these services together, including API keys and the Livekit server URL. At a high level, this structure is designed to keep the system modular, secure, and easy to scale. Now that we understand the overall setup, let's dive into the code and see how the agent actually works. Now, let's look at how the actual voice agent is implemented in code. I'll walk you through this at a high level so you understand how all pieces come together. I'm using VS Code to connect to my VM where I'm self-hosting my Livekit server. My customer support agent is also deployed on the same VM under the folder livekit_agent. I've currently opened the agent file, which is a Python file placed under the SRC folder. We start by importing all the required libraries. This includes Livekit for real-time communication, Deepgram for speech to text, OpenAI for reasoning, ElevenLabs for voice generation. We also load environment variables using .env, which allows us to securely manage API keys and configuration outside the code. Next, we define a main agent class called default agent. This class extends the base agent provided by Livekit. The most important part here is the instructions. This is essentially the brain of the agent. It defines how the assistant should behave. In our case, the agent is designed as a customer support assistant for a SaaS product. It is strictly instructed to always use a support underscore knowledge tool to answer any product related questions. This ensures that responses are accurate and come from a verified knowledge source instead of model guessing. We also define how the agent behaves, the rules for that. always acknowledging the user first, keeping the responses conversational, avoiding exposing internal systems for details, and following system guardrails. When a user joins, on underscore enter function is triggered. Here, we generate a session ID using the room and user identity. This is important because it allows us to maintain context across the conversation, even if the user reconnects. We also send an initial greeting to the user from the agent. Now comes the important part, the support underscore knowledge tool. This is implemented as a function tool. Whenever the user asks a question, the agent calls this tool to answer directly. This function sends a request to an external webhook where a RAG pipeline is implemented in n8n. The pipeline fetches the relevant information from the knowledge base like documentation, FAQs, support data. We pass two key things, the user question and the session ID for the context. The response is then passed and the final answer is returned back to the agent. We also handle errors like timeouts, invalid responses, or API failures to make the system more robust. Next, we define the entry point of the application. Here we are naming the agent called Customer Support AI Agent. This is very critical when we are implementing dispatch rules and when we are implementing more than one agents in our Livekit server. Finally, here is where we configure our voice pipeline. We are implementing Deepgram for speech to text, GPT-4o Mini, the language model, and ElevenLabs for text to speech. We also enable features like latency, response generation, and optional voice activity detection. Finally, we start the session by attaching our agent to the Livekit room. This is what allows real-time voice interaction between the user and the AI. At the bottom, we initialize the agent server and run the application. This essentially starts the voice agent service and makes it ready to handle incoming sessions. So overall, this code brings together real-time voice processing, intelligent reasoning, and the external knowledge retrieval into a single system. And this is what enables us to build production-ready AI customer support voice assistant. So that's how we built a real-time AI voice assistant for customer support using Livekit and LLMs. If you found this video useful and want to see more real-world AI use cases like this, make sure to subscribe to this channel. We'll be sharing more practical implementations, architecture breakdowns, and step-by-step builds to help you understand how AI can be applied to real business scenarios. And if you're looking to implement something similar for your business, feel free to reach out through our website. Thanks for watching, and I'll see you in the next video.